Okay, fourth graders, today we're doing Eureka Math Module 5, Lesson 18. And as you can see, we've been really working on adding and subtracting fractions. And so today we're going to challenge ourselves to add on to what we know by adding more than two fractions or subtracting more than two fractions. In an addition or subtraction problem, each number is called a term. So another way to say this is today we're going to add and subtract numbers or add and subtract equations that have more than two terms. Okay? Here we have a problem with three terms, 1/8 plus 3/8 plus 4/8. Copy the problem down into your notebook. And then I want you to just look at it, and we're going to do it like a number talk. Remember how we do number talks? What I want you to do is think about it in your head, and for each way that you can think to solve it, show me a silent finger. Go.
8 plus 3/8.
Sachi thought about 1/8 plus 3/8.
Which is 4/8.
Okay.
And then I knew that both of those 4/8 was 1/2.
So she thought about how 4/8
1/2 plus 1/2.
equals 1/2. And so she did 1/2 plus 1/2 equals 1. Good. Who else had a different way to solve this problem? Swarnima.
I did 4/8 plus 3/8, which is 7/8.
So you thought 4 plus 3 is 7/8. Okay.
And then I did 7/8 plus 1/8 is 12.
And then plus 1 more eighth is 8/8. Nice. Anyone else have a different strategy on how they solved it? Anshul.
I know. No, never mind. Sorry.
Okay, I never mind, sorry. Sanvi.
So I drew three I drew one big tape diagram.
You drew a big tape diagram, okay.
And then I split it into 8 parts, and then I shaded it and labeled it 3/8
Ah.
parts, and then 1/8, and then I got the answer.
So Sanvi drew a tape diagram and she divided it into eighths. Then she shaded it as it said. So it said 1/8. So she shaded 1. Then it said 3/8. So she shaded 3. And then it said 4/8. So she shaded 4. When she was done, she counted how many eighths she had, or also she saw that her whole tape was colored. So that was equal to one whole piece of tape. Very good. How could I use a number line to solve this? Remember, a number line is another picture that we've used to try to do this. We could do the same thing. We could split it the distance from 0 to 1 into eighths, right? And then we could start at 0. We can move 1/8. Then we can move 3/8. Then we can move 4/8, and we can see that we end up at 1. Okay? So today when you're asked to solve these questions in as many ways as possible, don't forget that tape diagrams and number lines are also really good strategies to use. Okay? Let's try another challenge. Here we go. We have talked about lots of different strategies that we can use to solve this problem. We came up with the answer 5/8. But the directions remind us to express the sums and differences as a mixed number when possible. So let's take a look at 10/8. Let's make sure we're writing it as a mixed number if it's possible. First, let me ask you, is it possible to write it as a mixed number?
Yeah.
How do you know that it's possible to write this fraction as a mixed number? Anushka?
It's more than 1.
How do you know it's more than 1?
Because 10/8 is more than 8.
I know that 8/8 in this case equals 1, right? And 10/8 is more than 8/8. So I can use a number bond to help me. I can say that there's going to be 8/8, but there's also going to be how many 8s left over? Everyone?
2.
So how do I write this as a mixed number? What's the whole number part? 1. What's the fraction part?
2.
And that's why it's called a mixed number, because it has a whole number part and it has a fraction part. Okay, very good. Okay, here's one student's work. Take a look and analyze it. The problem is 1 1/5 minus 2/5 minus 3/5. At your table groups, I want you to take a look at this picture and talk about what this student is doing. What strategy is he or she using? Go. Good analysis, you guys. So it seems like this student shaded in 1 1/5 and then crossed out 2/5 and then crossed out another 3/5, right? And then what was left and still shaded was the answer. Here's another student's work. See if you can see what they are doing. Take a look at what they're doing. They're not done yet. But what is their starting point? What are they trying to do? Talk at your table groups. You can see here this student is using a number bond. They're thinking of the 1 as 5/5 and 1/5 as 1/5. And so altogether 1 1/5 is equal to 6/5. then he or she can take away 2/5 and take away 3/5. In fact, we could think if I'm taking away 2/5 and 3/5, how many fifths am I taking away altogether?
5.
So I could think 6/5 minus 5/5 equals 1/5. Okay? So you are well equipped. You have lots of tools in your toolkit on how to solve these problems. Okay? Very good.